So to find the total number of cars turning left, we're given the rate at which the cars are turning left. So the number of cars turning left is going to be the integral from the time 0 to 18 of the L of t equation, that rate equation, which using the calculator, typing in L of t into the f1 of x. Then going to menu and analyze graph and doing the integral from 0 to 18. We get the value of 1,657.824, but we need to round to the nearest whole number, so it's 1,658 cars. So in part B, we have to find out when is L of t going to be greater than or equal to 150. On the graph, we have to take a look at when is that graph going to get above 150. So on the calculator, graphing that equation of 150, getting the intersection, storing those values into capital E, and then the other value of the intersection into capital F. So we've got the numbers 12.428 and 16.122. Then to find the average value of L over that interval, it's 1 over b minus a. So the average value is 1 over, we had used E for 12.428 and F for 16.122 off that graph. So 1 over F minus E, and the integral from E to F of L of t dt. And putting that into the calculator, we had stored E and F as those values. And F1 was the function we had used for L of t. So we have 199.426 cars per hour. Cars per hour comes from the fact that the 1 over b minus a was 1 over hours, and the integral made the cars. That's how the units come about. So for part C, we need to look at the product, total number of cars turning left, and a number of oncoming cars. So to set that up, number of cars going left multiplied by the number of oncoming cars. And that needs to be greater than 200,000, so greater than 200,000. We have 500 oncoming cars, so replacing that with 500. Then solving for the number of cars going left, number of cars going left has to be greater than 400. We're looking for a 2-hour time interval, so from some time to another time plus 2, in which that integral is going to come out greater than 400. So just picturing the graph, you've got one time and another time that's 2 hours away from that time, and that area has to come out bigger than 400. So if that distance at the bottom is 2, the height would be 200 in order to get 200 times 2, an area of 400. So just using two values, that would get that area to come out bigger than 400, using 13 and 15. On the calculator, getting the area, which comes out to 431.931. And since the integral from 13 to 15 of L of t dt does come out bigger than 400, then a traffic signal is required.